Mole Concept Part 1, High School Chemistry. Hello nerds, and welcome to this video on important concepts in high school chemistry. We were inspired to make this video by a family friend, Starlene Melody, who loves chemistry. In this video, we'll be discussing the mole concept, relative atomic mass, relative formula mass, mass from amount, amount from mass, molar mass from mass and amount, percentage composition in a compound, and empirical formula of a compound. These concepts are fundamental to understanding many chemical reactions and processes. Throughout the video, we'll be providing examples to help you understand these concepts. Stay to the end of the second video because we have explained real-life examples where you could apply these concepts. The mole concept is a way to quantify the amount of a substance. It is defined as the number of entities, such as atoms, molecules, or ions, in a sample of the substance. The entities must be of the same type, for example, atoms of a specific element. The number of entities in a mole is called Avogadro's number and is equal to 6.022 by 10 to the power of 23. This number is used to convert between the mass of a substance and the number of entities in it. For example, if you have a sample of a substance with a mass of 12 grams, you can calculate how many entities, atoms, molecules, etc., are in it by dividing the mass by the molar mass of the substance, the mass in grams of 1 mole of the substance. Relative atomic mass. Relative atomic mass, also known as atomic weight, is a value that represents the average mass of all the atoms of a specific element, compared to the mass of a carbon-12 atom, which is defined as exactly 12 atomic mass units, AMO. It is used to compare the masses of different atoms of different elements. The mole is a unit of measurement used to describe the amount of a substance. It is defined as the number of entities, such as atoms, molecules, or ions, in a sample of the substance. 1 mole of a substance is equal to Avogadro's number of entities, which is 6.022 by 10 to the power of 23. To use these two concepts together, we can use the relative atomic mass of an element to calculate the mass of 1 mole of that element. For example, if the relative atomic mass of an element is 12, then 1 mole of that element weighs 12 grams. We can also use the relative atomic mass to calculate the number of atoms or molecules in a sample of a given mass. For example, if we have a sample of an element that weighs 2 grams and we know that the relative atomic mass of that element is 12, we can calculate that the sample contains 2/12 moles of atoms or molecules. Here's an example of how to calculate the relative atomic mass of an element using its isotopic composition. Example. Calculate the relative atomic mass of chlorine, which has 2 isotopes, chlorine 35, 35Cl, and chlorine 37, 37Cl. The isotopic composition of chlorine is 75.77% 35Cl, and 24.23% 37Cl. Step 1. Determine the isotopic composition of the element. In this case, we know that chlorine is composed of 75.77% 35Cl, and 24.23% 37Cl. Step 2. Determine the relative atomic mass of each isotope. The relative atomic mass of an isotope is the mass of 1 atom of that isotope compared to 1 atom of carbon-12. So, the relative atomic mass of 35Cl is 35 and the relative atomic mass of 37Cl is 37. Step 3. Calculate the weighted average of the relative atomic masses of all the isotopes. This is done by multiplying the relative atomic mass of each isotope by its percent composition, then adding the products together. 35Cl% 35 plus 37Cl% 37 equals 0.7577 times 35 plus 0.2423 times 37 equals 26.39 plus 9.01 equals 35.4. So the relative atomic mass of chlorine is 35.4. Step 4, compare the relative atomic mass of chlorine to the relative atomic mass of carbon-12. Relative atomic mass of chlorine equals 35.4. Relative atomic mass of carbon-12 equals 12. So, one atom of chlorine weighs 35. 4/12 equals 2.95 times more than one atom of carbon-12. This is an example of how to calculate the relative atomic mass of an element using its isotopic composition. This method can be applied to other elements with multiple isotopes to determine their relative atomic mass. Relative formula mass of a compound, RFM. The concept of relative atomic mass applies to individual atoms of an element, but elements can also exist in the form of molecules or compounds. In the case of a molecule or compound, the relative molecular mass, also known as molar mass, is used instead. The molar mass is the mass of 1 mole of a substance, and is calculated by adding up the relative atomic masses of all the atoms in the molecule or compound. The relative formula mass, also known as formula weight, of a compound is the sum of the relative atomic masses of all the atoms in its chemical formula. It is a way to quantify the mass of a compound, and is usually expressed in atomic mass units, ARMU, or grams per mole, g per mole. Here's an example of how to calculate the relative formula mass of a compound step by step. Example: calculate the relative formula mass of glucose, C6H12O6. Step 1. Look up the relative atomic mass of each element in the compound. The relative atomic mass of carbon, C, is 12.01, hydrogen, H, is 1, and oxygen, O, is 16. Step 2. Write the chemical formula of the compound. In this case, glucose is C6H12O6. Step 3. Multiply the relative atomic mass of each element by the number of atoms of that element in the compound. For glucose, we have 6 by 12.01, plus 12 by 1, plus 6 by 16, equals 72.06 plus 12.096 plus 96 equals 180.16 grams per mole. Step 4. Add up the resulting values to get the relative formula mass of the compound. The relative formula mass of glucose is 180.16 grams per mole. So, 1 mole of glucose weighs 180.16 grams. It's worth noting that this method can be used to calculate the relative formula mass of any compound by finding the relative atomic mass of each element in the compound, and multiplying it by the number of atoms of that element in the compound. Here are a few more concepts we are covering. Mass from amount, amount from mass, molar mass from mass and amount, percentage composition in a compound and empirical formula of a compound. That concludes part 1 of our video on Introduction to Mole Concepts. We hope you found it informative and helpful. If you did, please give it a thumbs up and consider subscribing to our channel. Your support helps us create more content like this and make it more accessible to people like you. We also encourage you to leave a comment with your feedback or any questions you may have, and we'll be happy to respond. Thank you for watching, and we hope to see you in our next video.